Right, thanks everybody for coming out. I'm really happy to be here. Thank you to Christof Migone and to Felix for being here too. I'm very excited. I've brought a big, massive things to demonstrate and show. It's going to be really a hybrid between an artist talk and a performance and a discussion and electrochemistry demonstration. So yeah, I guess to begin, for those of you that were in Christof's class this morning, this might be familiar. These are handheld oscillators that I built and that I often perform with. And I'm not sure if they're going to feed back into the system or not, so I'm just going to turn this down a little bit. So yeah, I perform with these often. They're just basically little boxes. They have square waves, and I can tune them, and I can move with them. They're battery powered. And for me, when I use these, it's kind of like a way of activating space, of cleansing a space, of opening up a space with very raw, simple sound waves. So let's begin. So what we have here is just one tone, that's it. And any sort of vibration or fluctuation you hear is simply sound waves bouncing around the room. Basically, we're using the room as an effect processor of sorts. And when you add a second tone, then things get more interesting. Performance number one. I'll talk a little bit about my background. I moved to Montreal in 2004 from the West Coast. I was drawn there by the experimental music scene. It is quite vibrant, and there's a lot of amazing women in it. There's a lot of amazing everybody. It's a fantastic scene to work in. These are some very old photos of me. I think it was the first and maybe only time that I played 2 concerts in the same night, hence the same outfit. I used to go by the name Aircraft briefly when I was performing a lot in the noise scene. I would work with feedback, my grandfather's shortwave radio, some simple electronics that I built. I did that for quite some time. Eventually, I got a little bit bored of just the traditional concert setup, setting up your gear on a table in front of an audience and just performing, twisting knobs and things. I wanted to expand. I had this interest in space. I had this interest in architecture and in sonifying these things. And also, from a very early age, I was very interested in the invisible. My grandfather was a ham radio operator. And he would, ham radio, basically, it's an amateur radio club, and it was used during military times for like emergency communications. And basically they bounce signals off the ionosphere and to be able to communicate very long distances. So my grandfather would do demonstrations and show how like let us talk to his buddies like halfway across the world, and it was amazing. And he would tell us about the ionosphere and how at night, when the sky is clear, you get a clearer line to the ionosphere, the atmosphere surrounding the Earth, in order to bounce the radio waves. So from a very early age, I was just amazed with these like invisible radio waves all around me. So that's been a fascination that's really stuck. This is when I first built these same handheld oscillators. It was maybe 4 or 5 years ago for a project. I did, in Montreal, I also went through briefly the electroacoustics program there. That was one of the draws, experimental music and electroacoustics. And, I was already improvising, I was already performing, I was already, building my relationship to sound at the time. And when I arrived in the very traditional electroacoustics institution, which is basically, there's a canon of sounds, often they play on, very expensive 8 or 16 channel surround sound systems, and it's all about recording things and sculpting things for hours on end in software in order to make this perfect acousmatic experience with this very expensive sound system. And to me at the time, first of all, I wasn't really into the aesthetic of the music that I was being presented. Some of it's great, some of the early work, yes, but it, already having experience with sound didn't really work for me, so I kind of, in my way of kind of rebelling, I made these, and this, in a way, this is my surround sound system. My way of spatializing sounds with something that cost $4, and my body and movement, instead of this very complex and expensive system, and that I would have to spend, hours editing sounds in my computer. It wasn't really my thing. I'm much more into the immediate, the direct, feeling sound, touching sound. So that's more of my process. After I got over my thing with the noise scene and, setting up and doing my concerts, I started walking around the space with oscillators. I started amplifying surfaces. I started moving around the room more, extending my setup beyond the performance space. And the first project that I really did that in was called Other Dimensions. I was a huge sci-fi nerd, like my whole youth as well. So I'm really into the idea of like multiple universes, anything to do with space, like I'm all over it. And I basically had this realization one afternoon. I was sitting drinking tea, looking at the wall, and I'm like, in that wall is the infinite. There's, atoms, there's molecules, there's subatomic particles that actually aren't even physically touching each other, because matter is composed of things that are locked together. When you touch a surface, there's actually a very small electric charge between you and that surface. Like it's very complex and it's very overwhelming. So I just sort of had this experience, and I was like, we take everything around us for granted, and I want to make work that puts the sense of wonder into a table, the wall, walking down the street, just feeling this, how amazing and complex and inspiring even the simplest thing is. So that was kind of my inspiration behind Other Dimensions, and I'll play this little video for you. If it works. these are the same contact microphones used in this performance. And basically, what this is a disc. It's a piezoelectric disc. It's a microphone. And if you take this to any surface, touch this to anything, it basically turns it into a microphone, extending the surface of what is amplified. So I love taping these on the floor and walking around. Also, if you turn up the volume a bit, you get this really nice bass sound, which is simply bass feedback through the speakers. So I play a lot with making feedback with rooms, with surfaces, and with objects. At the end there, it was these circuits. So basically, that was my phase of really being interested in materials, in making surfaces and rooms feedback. And after that, I found this circuit. I made this circuit, which is basically, it's an amplifier circuit. So like your basic guitar amplifier, any amplifier circuit. It's very simple. It has like 5 components. And I designed it so that it's open. It has 2 antennas that basically amplify everything. So in the first time in the last performance, I was using it with really long antennas that I would then hold one and then like touch something metal in the room, touch a pipe, touch the plumbing. Basically, through the contact with my body and the circuit, essentially extending the range of the antenna and using the building itself as an antenna. That was something, that's something I'm very interested in. And after the Other Dimensions project, well, during actually, I started doing this piece called Electromagnetic Medium. Now, the electromagnetic medium, it's a term from physics and science. It's we're all bathed in one big electromagnetic spectrum. Everything that is material, electric, everything emits some kind of electromagnetic trace, and we are just existing within it and influence it by just standing here, by thinking. Our brains have electromagnetic traces, our thoughts, everything. It's pretty cool. So I started this project when I was on a trip in Athens, and I had these circuits with me. I was already on tour doing some improvisation, and I was like, well, thinking about this site, the Acropolis, what has gone on there? Like eons of amazing rituals and like spiritual experiences, like who knows what else, sacrifices, wars, like think of the history that's just embedded within the material there. So I was thinking to myself, well, why don't I just go to this site with these random amplifiers and work with them and see what I can pick up. And yeah, so basically, they're picking up radio waves, they pick up, interference from any electronics in the room, and then I play them. Well, I'm gonna play them for you, so I don't have to explain too much. But they also respond to touch, and I don't even have to touch them too, and it still affects it because my own electromagnetic signature is affecting it. So this is a series I still continue to do, and I really love these circuits. So I'll do a little performance. And there's the electromagnetic spectrum. Check it out. So, as you can see, they're very chaotic. And I don't have to do much for a lot of sound to happen. And I didn't mention it before, but my mode of production is really improvisation. I don't really compose in advance. I don't really structure my pieces too much. Sometimes before I perform, I'll kind of make a structure in my head to follow, but for the most part, I improvise. I set up very chaotic systems, and I go with them and see where they take me. I really love to be surprised, and I find I really enjoy being forced to be vulnerable, being not in control, being simply here to kind of channel natural forces rather than command them as my art. You know, I sort of have that's my view of creation. And because I work with very simple circuits, I don't spend a lot of time like soldering things. I often keep them on breadboards open. So really this has allowed me to spend a lot of time engaging directly with the signals, experiencing the sound instead of spending a lot of time designing and soldering and troubleshooting. That's been my method of production. And yeah, it's really given me time to build a very strong relationship to the sounds I'm working with, even though they're very minimal. Moving on, here's another fun little thing of electromagnetic fields from sort of a new age kind of book, you know, talking about, you know, electromagnetic fields, the fields around the human body. I'm also very interested in this. I do come from the West Coast. My father is a Reiki master, also a karate instructor. He was a science teacher for a while. It's very complex. But I do definitely grow up in a culture of, you know, new age, magic crystals, you know, cosmic consciousness. This is very much ingrained in me. It's something that I've had varying levels of comfort with. I've, you know, hated it. I've been open to it. I am very skeptical as well. But it's something that's definitely has an influence. Thinking about, as Christof was talking about, the beyond. Like what is, you know, back to the electromagnetic spectrum. you know, the rainbow in the middle, that's what we see. And everything else is also there. And, you know, let alone like what kind of frequencies we can hear out of all the frequencies that exist. You know, we directly experience a very narrow range of what is existing around us and passing through us all the time. And that's kind of a scary thought, but I prefer to see it as super inspiring. And that's something that allows me, when I'm working with these very simple analog tools, to just really get into it, to stay fixated on like a hissing sound for a very long time, because it's not just a boring hissing sound. It's like, you know, it's particles, it's radio waves being emitted from a distant star. It's like somebody in another dimension trying to communicate. Who knows? Like, who knows? You know, not like I'll ever be able to prove it with this kind of setup, but it sure is fun to, you know, try to search for emergent properties of these chaotic systems, just to wonder what is trying to express itself. What am I tapping into? Let's see. Great. So yeah, after a long time improvising with electronics, starting to explore space and, you know, electromagnetic fields and all that, I wanted to expand my process further. You know, I've been working with sound for over 10 years now, and pretty much 8 of that was spent doing a very similar practice of improvisation and improvisation with space. So I felt like it was time to try something else. So I went back to my childhood rock collection. I had a really big crystal collection in my West Coast youth, so I started amplifying them, using them as objects to work with in my performance. And eventually, in doing that, I was like, well, what about trying to sonify the process of crystals growing? Why just use my childhood rock collection? So that led me to my project, Crystalline Domain. I pitched a residency to Studio XX in Montreal, and they welcomed me with open arms. They were really excited about it. So basically, I started growing crystals. I had no idea what I was doing. So I searched on the internet how to grow crystals. And, you know, of course, you have to know a little chemistry. You have to know how to make a supersaturated solution. So basically, I just started trying to grow crystals and doing some research, and, you know, did a lot of video and stuff like that. And also, some of the research also took me to early alchemy, which is the foundation of chemistry and physics and basically all science. And it was a practice that was not purely about, it wasn't purely scientific. It was involved mysticism, involved in astronomy and all kinds of things. It was, you know, this is Maria Prophetissima. She was one of the early alchemists, and she actually invented a lot of the equipment that was the basis of chemistry equipment that we use today. This is the bain-marie, Maria's bath. She invented this along with many other things. You know, a lot of the glassware is still similar in shape to the things that the early alchemists were using. Another alchemist, Cleopatra was her name. It's not her real name, but that was a name given to her. She was, you know, one of the founders as well, like before, you know, 0 AD. And she had this amazing book. I would love to see a copy of it someday, the Chrysiopoeia Cleopatra, and it's just full of all these alchemical symbols, and she made a lot of contributions to the practice and was spoken about a lot in history. And this Ouroboros, it's the snake eating its tail, the eternal return. This is an alchemical symbol, and it's something that I became interested in terms of, you know, thinking about going into matter and experiencing the micro world, and also thinking about how the structures of atoms and molecules and electrons, there's resonance with the cosmic scale, with planets and solar systems. So I started thinking a lot about, you know, extremes looping around and meeting, the micro and the macrocosmos coming around to meet. And during my Crystalline Domain residency, this is a contact microphone with some sugar crystals growing on it. And I looking at it under the microscope, it looked like a planet with stars, and I was like, wow, okay, I got the idea to try to, replicate cosmic-looking things under a microscope. So I'll just briefly play a bit of the results of my residency. I'm quite interested in syncing sound and image in this manner, getting really close into something and then having it just little movements being amplified. It's the way of intensifying the experience of matter. That's a copper sulfate solution. Wires that I'm running an oscillator tone into, and then just moving them and building a drum with exact same circuits. And this part was really inspired by my first electronics project when I was really small. My father brought home, and it was to build a crystal radio set. And me, with my obsession with crystals as a young child, I imagined it to be this like crystal radio with like big crystals all over it, and it'd be so fun. And we built it, and the crystal in the radio is like this tiny little thing encased in plastic. It doesn't look like a crystal at all, and it just basically allows you to listen to the radio really, really quietly. So I was very disappointed, so I kind of wanted to remedy that, to fix that childhood memory through this piece. So yeah, again with the Ouroboros, I'm very interested in alchemy, mysticism, New Age, and kind of how we can bring these things together with hard science, theoretical physics, the origins of the universe, cosmology, because there's a lot. It's kind of a dichotomy. There's a lot of it doesn't really, again, the theme of paradoxes and problems. There's a big problem between, spirituality and science. And this is a zone I'm really interested in exploring, trying to kind of unpack the differences, trying to play between them, working between science and pseudoscience, between, mysticism and theoretical physics. So this is, again, it's, an astrophysicist using the alchemical symbol of the Ouroboros to try to sort of make a scale of everything in the universe from humans to galaxies, and then you have molecules, DNA, dark matter, it's sort of, he's trying to, link it and see what is the meeting place between these two scales. What could that be? I find this quite interesting. I'll just briefly talk about this. It's this amazing theory. Dr. Lee Smolin, he's working between University of Waterloo and Toronto. He's a theoretical physicist. And he has this great theory that the fecund universe, fecund is in fertile, is in giving birth to lots of things. His theory is that what a black hole is actually the negative space of another Big Bang. Like, that's pretty cool. And that actually black holes are just, that they're basically creating whole new universes, not necessarily like our own, perhaps with completely different laws of physics than our own, perhaps universes that last for a split second, as long as the black hole does, because black holes, they pop up in a lot of places, but most of them are very small and so unstable. They last for a fraction of a millisecond, but it's when they're big, when they get big out in space, when they suck in enough matter and get enough juice that they actually become stable enough. And who knows, perhaps that's one way, that it's another way of understanding theoretical physics instead of multi-universe theories. It's like this sort of evolutionary living cosmos that is constantly giving birth to other cosmoses. It's a theory I really love and I find very inspiring, and it really reminds me of fractals. I really like fractals. They're everywhere in nature. They're everywhere in crystal structure. They're just everywhere. It's this fundamental. Basically, as soon as you have a feedback loop in mathematics and a certain algorithm, fractal structures begin to form, and that's basically how a lot of matter and complexity and life and nature is constructed in these very simple patterns that feed back on themselves and evolve. So that's something I'm very interested in exploring in my work. This is me in the lab. This is the next phase of my crystalline domain installation project that I just showed, that actually just exhibited this year. I decided to crystallize 3,000 of these guys. If you'd like to pass them around. You guys are going to go home with one each, so you don't need to look. So basically, they're makeup sponges that I ordered 3,000 of them from, and crystallized borax crystals. It's a basic, it's a laundry detergent. It's it's a boron salt. It's mined from the earth. It's a natural product. So I grew crystals on them, mixing them, putting them in bins, letting them sit overnight. So that was really fun. I also grew Epsom salt crystals, which I'm going to be making some solutions in a moment. This is a prototype for an electronic component made from a crystal. So I would first grow a small Epsom salt crystal, and then I would hook copper around it, and then I put it back in a solution, and it would grow. So basically, this is like something I use to run electricity through and run light through, and then this is an installation view of my 3,000 borax crystal sponges. I put them in piles, and again with the idea of the fractal, of self-similarity in nature. To me, the small triangles mimic, they mirror the structure of the crystals, and having many multiples of them in one place, lit only by a few LEDs here and there. For me, it's sort of a metaphor for the observable universe, like what we can see, and then what exists beyond. So that's something I'm working with there. This is the result of the Epsom salt copper crystal component sculpture thingies that I wired up like this little cybernetic network. I kind of like to view the LED as an observer in theoretical physics. The observer is very important, like us as an observer, or it can also be an object observing another object. That's an idea that's very important in cybernetics and things like this. So I kind of like to play with that in these very rudimentary systems like wire, copper, crystal, imagining that this maybe, someday this thing will have a communication and talk about something, have some kind of memory together. And this brings us to my project phase space that I'm going to start to demonstrate now. So this is just, basically this hopefully will happen tonight. It depends how long I do my thing with the circuits for. Basically, I'm performing a process called electrolysis that Felix, I think, will probably explain much better than me after. But basically, I have all of these circuits that I plug in to the solution, and by the process of running current through a salt solution, it causes ions to jump off molecules. So it makes changes happen. Copper ions jump into the solution, and eventually they make the solution appear blue. It's transforming the structure of the solution that I'm working with over the process of the performance. So yeah, I'm going to put some salt in here. I'm using the same contact mics I was talking about before. First, before I start to mix the salt, I'm going to show you what Epsom salt, magnesium sulfate, the salt I'm working with, looks like under the microscope. This is a microscope video camera. I use it in performances, and I used it as well during my crystalline domain installation. So there they are. You can see they're small little crystals. It's Epsom salt, obviously is available at any pharmacy. And I like to use it because, one, it's pretty safe, and because I don't really know much about chemistry, I don't want to do anything stupid, so I like to stick to things that are quite safe. And also it already, as my interest in physicality and the body and attaching sound to the body, you know, Epsom salt's used to soak tired muscles. It's something that we already associate with making our bodies feel better, so I thought it was an appropriate substance to work with for that reason. And also because it turns blue, which is fun. So what this is here is a magnetic stirring hot plate. It has a heating element. I picked this up from like a used chemistry supply place in Montreal, which is just amazing. And this is a magnetic stir bar. It stirs because there's a motor inside that spins. So get this going. And it also makes a really nice sound. And a really cool vortex. Microphone mounted on the microscope, so what we see up close we can hear up close too. to make a supersaturated solution, you basically have to add a whole lot of salt until, basically, the way crystallization works in this method, when water is room temperature, the molecules are moving slower because it's cooler, and you can only melt a certain amount of salt in it. But when you heat the temperature, the molecules are moving much faster in the solution, so that allows you, because of the fluidity and the movement, it allows more salt to dissolve than at room temperature. So then what happens is when you cool the solution, there's no place for the extra salt to go. That's why it's called supersaturated, too saturated. And that's when the crystals, or the salt molecules rather, are forced to get together in the most efficient structure possible, which is tightly locked together in a rigid geometrical crystalline structure. Feedback I was talking about. Okay. I doubt this solution is perfectly supersaturated, but it'll have to do for our purposes today. Okay. So this is an Erlenmeyer flask. It's really good for mixing. This is a Florence flask, which is my favorite these days. I just find them very, very beautiful. So I'm going to pour some in here, and then I'm going to move to the next phase, which is making sounds with these solutions with electronics. And you were asking me about what the sticky tack's for. You know, because I'm putting wires in and moving wires out, I like to just, a little fail-safe is I put sticky tack under my beakers, because if they were to turn over during a performance, that would be pretty bad. So put a little down. Stir bar out of my solution, this is just another magnet. So in the stir bar, there's basically two magnets that spin because there's another magnet spinning underneath. Let's see if I can pour this without dumping it everywhere. Wish me luck. So first I'm going to get this guy going here. So already it's making sound. hydrogen and oxygen bubbles that are the water is basically being separated, and the hydrogen and oxygen bubbles are bubbling up to the surface. And at the same time, there's other things happening too. When I will be adding more circuits, you'll see it more clearly. Also, part of these circuits is something called a thermistor. It's a temperature-controlled resistor, so the circuits change with temperature too. And then as I always want to involve my body in the circuit somehow, I also have a couple of body contacts that again change the circuit. That fluctuating tone you hear, this is a new circuit. I had a real electronics wizard friend of mine help me develop, and we call it the molecular amplifier. Basically what it's doing, it has 3 stages of amplification that are amplifying this bubbling, changing process in the solution, and that fluctuation is then used to control the voltage on another oscillator. So that's an expression of the fluctuation at the molecular level, that tone right there. But I do like a lot of weird sounds, but I do get sick of the higher frequencies after a while, so Felix was kind enough to hook me up with some dry ice for tonight. So we're going to cool the solution, and dry ice is a solid form of carbon dioxide, and it stays solid at about minus 70 degrees Celsius, so it's very, very cold, so cold it can burn you. acoustic sound, the amplified sound of dry ice sublimating in water is really, really nice. So I'm going to put another piece in and I'm going to amplify that for a bit. demo of my piece, Face Space. And I guess that's about it for my part of the presentation. Now I'd like to invite Felix to come give us his insights and yeah. Thanks.
Thank you, Erin. That's a very beautiful performance and a beautiful demonstration. So a little bit about myself. My name's Felix Lee, and I'm from the chemistry department at Western. I've been at Western for 10 years, and I have a fairly interesting history, kind of like Erin as well. I didn't grow up in a family of chemists or scientists. I actually grew up in a family that was highly, highly art-oriented, believe it or not. My father was trained in the fine arts in Manitoba and also in England, and he started his own graphic design business. I was immersed in art as well. My favorite toys as a kid were Pantone swatch books, believe it or not. So I came from a art-filled background, and somehow I moved towards chemistry. But between the two of them, I had a huge interest in electronics as well. In grade 5, I started building circuits. Those were my science projects. And by about grade 10, I moved entirely into chemistry. Okay? And the reason I moved into chemistry is because I like to see how things work, be able to explain how things work at the molecular level. Okay? And from that point on, it's been chemistry ever since, because chemistry allows us to explain observations. It allows us to explain phenomena. For example, colors. So Erin had shown a slide earlier where the solution turned blue, and I believe there is a slight tinge of blue in her Florence flask here already. Okay? So being art-oriented, I can actually pick out very, very slight colors, because in chemistry you're used to picking out fine changes in color as well. So there's a slight blue there, and we'll get into that blue in a little bit. So I like to explain things at the molecular level. Electronics help us observe what our naked eye cannot see. So Erin had talked about the electromagnetic spectrum. We see colors. Colors are just that tiny little sliver of the electromagnetic spectrum. We cannot see infrared light. We cannot see UV light. Now, some organisms could. Okay? It's rumored that birds can see UV light. Mosquitoes could see infrared light, but us humans are very limited to that narrow band in the electromagnetic spectrum. Okay? So in chemistry, we observe what we cannot observe using fancy electronics. We use scientific instruments to help us see what we cannot see. Okay? So there's really a connection between chemistry and electronics, even though most people don't think of chemistry as being highly electronic. Okay? Most people think of chemistry as being bad for you as well, because you hear the chemistry in the news, right? You hear about chemicals in your food. You go and buy a pack of chemical-free bananas, but there's really no such thing as chemical-free living, because we are all made out of chemicals. Water is a chemical, and water is a big proportion of your body. Okay? So it's interesting that we can see a lot using electronics, and chemistry is really all around us. Okay? So the basis here really is electrolysis. So who knows what electrolysis is? Now there are really two words in electrolysis. Okay? Electro refers to electricity. Now the other word, lysis, is a scientific term that's actually carried over from biology. Okay? Lysis means to break open or to break apart. So electrolysis really refers to the use of electricity, electric current, to break something apart. Okay? So what Erin has done is she's taken her flask and put wires in there. And two of the various wires supply electricity that comes in the form of little 9-volt batteries. Okay? Now in chemistry, 9 volts is considered a little bit high, because that is more than enough to drive many chemical processes to go. Okay? Now, how many of you heard about hydrogen fuel cars? Now you heard of hydrogen fuel cells and hydrogen fuel cars? You buy a car, you fill up hydrogen, and the news tells us the only thing that spews out of the tailpipe is water vapor. Okay? So a hydrogen fuel car works by reacting hydrogen gas with oxygen gas. And that releases energy, and that is what moves the car. Okay? Now, we saw bubbles here. Who remembers what those bubbles were? Those bubbles.
Hydrogen and oxygen.
Hydrogen and oxygen. Okay? So what Erin has done here is the opposite of how a hydrogen fuel car works. So a hydrogen fuel car takes hydrogen that's stored, in the trunk, that's stored underneath the seat, reacts with oxygen in the air. You burn hydrogen with oxygen to give you energy and water. So to go backwards, to go from water back to hydrogen and oxygen, you got to put energy in. Okay, and that energy comes from the little 9-volt battery. Okay, so in chemistry, the way we see it is that we have things reacting. Hydrogen is H2, oxygen is O2, and we get water, H2O, out of it. Okay? So going from hydrogen and oxygen to water gives us energy. To go backwards, we got to put energy into this flask here. Okay? So that's where those cute little bubbles come from. That doesn't turn blue yet. Blue enough that we can see. And I can still see it bubbling here. It's quite nice.
Yeah, like for this solution to actually turn blue during a performance, I'd have to have more current and maybe less water. I also didn't maybe put enough salt, but eventually, if we were to leave that there, it would be blue like the picture.
I can see a slight, very, 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 very faint hint of blue, but it's coming. It might be there by 9 o'clock tonight. So electrolysis is all about using electrical energy to force a chemical process that otherwise wouldn't occur normally to occur. Okay? Now, that's one thing. You see those little bubbles here. But the blue part is the really neat part. So chemistry is all observing. You observe hydrogen and oxygen being formed. You observe color changes. So in our first year chem course, one experiment that students do is they go in and they combine different chemicals and see if you change colors, see if you form a solid, you get this little powder form. Chemistry is really about observing. And observing is really an art. To observe is an art. You got to be able to see what's going on, describe what's going on. In chemistry, we also like to blow things up. Right? The classic chemical experiment, chemistry is all about sound as well. Okay? So there's water here, there's hydrogen, there's oxygen. The blue is the interesting part. Okay? So Erin, you start with something that's completely clear and it turns this bluish color. Okay. Anyone want to take a guess as to what that blue is? Yes?
Copper?
It's copper. Okay. But we're going to be a little more specific. What color is copper itself? Regular, everyday copper. Copper, okay, great, okay. You talk about the now extinct copper penny, okay? So copper has a very, very characteristic color to it. Can I take this one? Yeah, okay. This is what copper looks like. It's the characteristic copper color, okay? It looks like copper. It's copper, okay? So this is what copper looks like, okay? There's no other word to describe it. It's a distinctive color. It's brownish, bronzy, kind of copper colored. Okay? But why blue?
It's oxidized.
It's oxidized, that's right. Okay? So the key here is that we've got a chemical process going on. Different elements show different colors when they're in different chemical states. Okay. So for those of you who are into painting, the paints that you buy are all of different colors. They're all different chemicals. They're all of different compositions. But two of them might have the same element, but in different chemical states. Okay? So copper that you get in a copper penny is metallic copper. Copper that you get in copper wire, if you strip apart an extension cord and you see that copper color, that is metallic copper. Okay? That is pure copper. It's element Cu on the periodic table. And that is metallic copper. Now the metals dissolve in water. Okay, go home, take some tin foil and chuck it in water. Does tin foil dissolve in water? No. It doesn't. It just sits there. Okay, a tin can doesn't just dissolve in water. Okay? Unless there's a chemical change that occurs. Okay? Steel is made primarily of iron. A piece of steel doesn't dissolve in water. But your car will dissolve away in the form of rust. Okay? It's because there's a chemical change that occurs. And in electrolysis, one thing we could do is oxidize. And in oxidation, what you do is you take the neutrally charged form, there's no charge here, and you remove electrons. And when you remove electrons from copper, what you get is copper 2+. So you strip 2 electrons out of copper. Okay? And copper 2+ is what we call an ion. And ions are soluble. They can be dissolved in water. Now this is copper color. And magically, when we get the copper 2+ form, it's blue. Okay. Now, in chemistry, things have to balance out. If you remove 2 electrons from copper, who gets the 2 electrons? Is it oxygen? Close, yes.
The chlorine? Wait, no.
Good guess, there's no chlorine
I mean,
in there.
if NA, but is that, what kind of salt is that actually made
That's
of?
magnesium sulfate dissolved in water.
So the magnesium and sulfate is going to split.
Possibly. For that, we actually have to understand a bit about redox chemistry. Chemistry is about likeliness, too. So if you have 4 competing processes, one process is more likely to occur than the other. So it is possible to give the electrons to magnesium sulfate, but in this case, the electrons are given to water, and that's where we get the gases form, the bubbling form. Now, where does that copper initially come from? If you look at the wires that she's using, can I pull one up?
Yeah, of course.
Okay.
100%.
Trying to find one that has copper on it. There is one. The yellow one. Can I take the yellow one?
Of course. Can I put some more dry ice in there?
Sure. So if you look at the yellow one here, there's that coppery color right there. Try to match by. There you go. That's copper right there. So it's the little wire here that's supplying the copper metal. And during electrolysis, the copper is electrolyzed and oxidized into the ionic form. Okay? So if we look carefully, we can actually see that this copper wire here has been eaten away because metallic copper, like your penny, doesn't dissolve in water, but the copper 2+ form does dissolve in water. Okay? So over time, this gets eaten away. So that's an observation. Over time, you'll see it turn blue. It's a very beautiful blue. And you could use other metals as well. If you use like a nickel wire, nickel is Ni, and if you have your Canadian nickel, it's a substantial amount of nickel. Nickel, again, being any metal, does not dissolve in water. But when you strip electrons out of it and you oxidize it, you get nickel 2 plus. That's a beautiful green color. So by taking different chemical species, you could, for instance, make green colored paint, blue colored paint. In Britain, they used to use cadmium for the yellow road paint, and cadmium was extremely toxic. So nowadays, they use different alternatives for different colors of paint. What else was there? I can't remember. Dry ice. Okay. How many have actually played with dry ice? Some of you know. Okay. Dry ice is a very interesting compound. Okay. It's carbon dioxide, the stuff that you're exhaling. Let's play with dry ice here.
I'll take some around and show
Sure.
people.
Don't put it in your mouth or you'll get your tongue stuck to it, like licking a metal pole in the winter. Okay. Sure. So Erin talked a little bit about sublimation, and sublimation is a mixture of a chemical and a physical process. Physics and chemistry really are to some people the same thing. And it's really a phase change here that's going on. So if you look at water, that's in the solid form, H2O, S for solid, that's ice. What water does when the environment warms up is it goes to liquid, which we know is water, and then if it warms up even more, it goes to gas or water vapor or steam. Okay? So you go from solid to liquid to gas, you melt, and then you vaporize. But if you go from here directly to there, that is sublimation. Now water can sublimate under some conditions. If you leave food in your freezer for too long, like you put a piece of meat, your steak, leftover steak, into a Ziploc bag, and then your steak sits in the freezer for 6 months, it gets freezer burned, it's all dry and stuff, it's because the water has sublimed out of that piece of meat. Okay? So that's common with water at certain temperatures, especially if it's really cold and frozen. Okay, that's how freeze-drying works. You buy freeze-dried food, freeze-dried items of all kinds, freeze-dried bugs if you want to do that. Okay? But dry ice at -70 is kind of like ice. Okay? It goes right from solid to gas. See, so this doesn't melt. If you pick it up in your hand, it might give you frostbite, but it doesn't melt into liquid. It goes right from solid to gas. Okay. Now, this is also effective at cooling things at -70. You know, if you have drinks that you really want to cool down quickly, it's way more effective than ice cream. And it gives you a beautiful display too, because you see this white smoke, which really isn't smoke, coming out of the flask.
See, I was so distracted by the dry ice, I forgot to put my crystal video on. So these are Epsom salt crystals, the same component same salt I'm using here that crystallized, and this is them under the microscope. So yeah, there's that too.
All right. Well, thank you.